Dear learners, let's consider some examples. Number one, a note phonograph record revolves at 45 revolutions per minute. What is its angular velocity in radians per second? Then, once the motor is turned off, it takes 0.75 seconds for the phonograph record to come to a stop. So what will be its average angular acceleration? And how many resolutions does it make while coming to a stop? The 45 revolution per minute given is also the angular velocity. But the first part, A part, wants us to provide the answer in radians per second. We know that because we know that one revolution is 2 pi radians and 1 minute is 60 seconds. So you can straight away do that. Then that phonograph is revolving. Then someone decided to stop it and it took 0.5 seconds for it to come to a stop. So the time to come to a stop is 0.5 seconds. And coming to a stop means that its angular velocity becomes 0, omega becomes 0. And this we can target as the final angular velocity, omega f. And this, the 45 revolution per minute, is the omega subscript I. So you can obtain angular acceleration. Then you can obtain the angular acceleration alpha. Then how many revolutions did it make while coming to a stop? And that is the number of revolutions, theta. So very straightforward, you can do it. Solution. The initial angular velocity, 45 revolutions per minute, if you convert to radian per second, means you have 45 times 2 pi radians, then over 60 seconds. I told you revolution means 2 pi radians. 1 minute is 60 seconds. So if you press that, you can leave your answer in terms of pi. That is 3 pi over 2 radian per second. And you may want to just get in decimal. So 22.2 over 7, then you have pi. You get your answer in decimal. Okay, now let's start. Now we've obtained the initial angular velocity in radian per second, which is what we have here. And the question now says the angular velocity becomes 0, it comes to a stop. And it took it 7.5 seconds to come to a stop. Calculate the angular acceleration. So on the formula that is known, you have recall one of the equation of motion, that's alpha, which is the angular acceleration, is the rate of change of the angular velocity. That is minus the subtracting the initial angular velocity from the final angular velocity divided by time. Omega subscript f minus omega subscript I over t. So substituting 0 where you have subscript f, I is 0 here, and here you have your 3 pi over 2 radian per second. Then your t is 0.75 seconds. Okay, so you have it, and if you compute, to answer will be minus 2 pi radian per second square. So your alpha as negative sign shows that it is decelerating. That is, the velocity is decreasing with time. That's what it means. So decelerating. And that's why it comes to a stop. So negative sign shows that it is decelerating, that there is a decrease in the angular velocity as the time goes on. So the answer is minus 2 pi radian per second square. That's the angular acceleration. Negative sign shows that this value is that it is decelerating. That's the emphasis. Okay. For this third part, the number of revolutions that the revolving phonograph record makes in 0.75 seconds. And that's theta. And that also one of the equation of motion will be useful here, where we have our theta equals omega subscript I t plus half alpha t squared. You know the value of your omega subscript I, which is 3 pi over 2 radian per second. The time is 0.75 seconds, then plus half into bracket. Your alpha is minus 2 pi radians per second squared, and your time is omega squared, so 0.75 seconds squared. And if you compute that, your side, left hand side of the plus sign, you have 1.125 pi radians. Then the other part, the right hand side of the plus sign, you have minus 0.5625 pi radians. And if you further compute, further solve it, your answer will be 0.5625 pi radians. So I can leave my answer in radian. However, number of revolution is best to obtain it in terms of revolution. And we know that 2 pi radians is equal to 1 revolution. So from that, we can obtain 1 revolution. Recall that 2 pi radians equals to 1 revolution. Therefore, we have that our value theta will be 0.5625 pi over 2 pi revolutions. Okay, and from there we have 0.2 revolution. So not even up to half revolution, just not even up to 1 revolution, not even up to half revolution. Just turn a little in that time. Okay, so please just study this example very well. It's very straightforward, as you can see. Very, very straightforward. I hope you understand this. God bless you. And please watch other videos to see other examples.